So, steganography is the practice of hiding secret information within an ordinary non-secret file or message to avoid detection. So the word originates from the Greek word steganos, covered, and graphia, writing, meaning covered writing or secret writing. So unlike cryptography, this meaning covered writing, right? So unlike cryptography, which makes a message unreadable or to outsiders, steganography makes the message invisible and undetectable. So the hidden information can be embedded in images, in audio files, in videos, and text documents, or even network protocols. For example, a digital image might look completely normal to the naked eye, but it could contain an embedded message within its pixel data. So the main objective of steganography is to communicate information secretly so that only the intended recipient is aware of its existence. So we need to look at how is steganography different from cryptography. So both steganography and cryptography aim to protect information from unauthorized access, but they do so in fundamentally different ways. So cryptography transforms the original message, which is the plain text, into ciphertext using an algorithm and a key. So the result is a message that is unintelligible to anyone without the decryption key. However, the presence of ciphertext is obvious. Anyone intercepting the message knows that it is encrypted and may attempt to break it. Then steganography, on the other hand, does not alter the format or the information in an obvious way. Instead, it hides the very existence of the message by embedding it within another, seemingly innocuous file or medium. For instance, a text file, an image, an audio clip may appear completely normal but actually contains hidden data. So if someone intercepts a steganographic message, they may not even realize that there is a secret message to look for. So in summary, we are saying that cryptography protects the content, while steganography protects the existence of the communication. For example, if Alice sends Bob an encrypted email, Eve, an eavesdropper, can see that someone's secret is being sent, even if she cannot read it. If Alice hides a message inside a family photo using steganography and sends it to Bob, Eve may see only an ordinary photo and suspect nothing. So we need to look at the techniques, steganographic techniques that we have. We have text steganography. This one involves hiding information within text files. This can be achieved by altering the structure or content of the text so that the hidden message is not apparent. Several techniques are used in text steganography. There is format-based, which is changing the format of the text, such as adding extra spaces, tabs, or adjusting line breaks in a way that encodes information. There is a random and statistical generation. This one is generating random looking text, altering the statistical properties of the text to embed data. For example, generating a sequence of words or characters that, when decoded, reveal the hidden message. Then there is linguistic methods using synonyms, paraphrasing, or context-free grammar to generate readable text that contain hidden information. For example, the first letter of each sentence or word could spell out a secret message, right? So, for example, a poem where the first letter of each line spells out a hidden message, or a document where every second space encodes a binary value. This is what we call that's what text steganography. Then there is image steganography. This one is one of the most popular and effective forms of steganography. It involves hiding data within the digital representation of an image. So since digital images are made up of thousands or millions of pixels, each represented by bits, small changes can be made to these bits without noticeably altering the image. So there's least significant bit insertion, right? This one is modifying the least significant bit of pixel values to encode the secret data. For example, changing the last bit of each color value in a pixel can hide information without visibly affecting the image. Then there is masking and filtering, applying image processing techniques to embed data in significant areas of the image. Then there is redundant pattern encoding, using patterns in the image's data that can be altered to carry information. Then there is encrypt and scatter, encrypting the message first and then hiding it in random locations within the image. Then there is coding and cosine transformation, embedding data in the frequency domain of the image using techniques like discrete cosine transform, commonly used in JPEG images, right? Then we move on to video steganography. This one extends the principles of image and audio steganography to video files, which are sequences of images or frames, so and often include audio tracks as well. So this allows for hiding much large amounts of data due to the size and complexity of video files, right? So here we are saying that in video steganography, you can hide kind of data in digital video format. The advantage of this type is large amount of data can be hidden inside, and the fact that it is a moving stream of images and sounds. You can think of this as a combination of image steganography and audio steganography. So there are two main classes of video steganography. One, embedding data in uncompressed raw video, right? The secret information is inserted into the video frames before compression, allowing for more control over the hiding process. Then embedding data directly into the compressed data stream. Data is hidden within the compressed video, such as in MPEG or AVI files, often by manipulating the compression algorithm's output. And then we move on to audio steganography. In audio steganography, this one involves hiding information within audio files. This is more challenging than image steganography because the human ear is more sensitive to changes than the eye is to slight color variations, right? So the techniques include the least significant bit of encoding, and this one is similar to image least significant bit. The least significant bits of audio samples are modified to carry the hidden message. Then there is parity encoding. Parity bits are used to encode the message within the audio. Then there is phase coding. The phase of the audio signal is altered to embed data, which is less perceptible to human hearing. Then there is spread spectrum. The message is spread across the frequency spectrum of the audio file, making it difficult to detect or to remove. Then there is network steganography. This one hides information within network traffic, such as TCP, UDP, or CMP packets. This can be done by manipulating the optional fields in packet headers, altering the timing of packet transmissions, or using covert channels within network protocols. Because network traffic is fast and dynamic, small changes can go unnoticed. For example, information is hidden in the unused fields of a TCP/IP packet header, or by varying the timing between packets to encode data. These are some of the tools that can be used for steganography. You can just see and read on your own. So in conclusion, this signal is a powerful tool, a technique to convert communication, offering a way to hide information in plain sight. So unlike cryptography, which makes messages unreadable but obvious, steganography conceals the very existence of the message. So from text and images to audio, video, and network protocols, steganography can be applied in many forms, each with its own methods and challenges. So as digital communication continues to evolve, we need to understand that steganography is essential for both protecting sensitive information and detecting hidden threats in the field of information security and cybersecurity. So this marks the end of our lecture, and thank you for listening to this presentation. If you have any questions, you are free to write them in the comment section. I will answer. Thank you.